In this video, we are going to see about how to convert an XS3 code to BCD code. First, we will see what is a BCD code and XS3 code. Then, what is the step-by-step procedure to convert the given XS3 code to BCD code. What is a binary coded number or BCD number? It is actually a method to represent the decimal number. So we know decimal numbers ranges from 0 to 9. So BCD also has the numbers from 0 to 9, but the difference is that this decimal number will be represented using binary numbers 0 and 1. For decimal number less than or equal to 9, both the binary number and BCD are same. Whereas for decimal number greater than 9, you have to add 6 to the binary number to get the BCD. If you want to some detailed explanation about binary coded decimal number, you can refer to the previous video on binary to BCD code converter, where I have explained about BCD in detail. Now you see this example 2, it is represented in binary form 0010. This is equivalent to BCD also because this number is less than 9. But if you take a number 52 which is greater than 9, you see here for this 5 separately 0101 is written. It is actually binary equivalent of 5. And for this 2, I have to write 0010, that is 2. So in BCD, we will write the numbers separately. You split the decimal numbers and write the binary equivalent separately. XS3 code. It is actually a modified form of BCD. So if you have a BCD number, if you add 3 to it, you will get the XS3 code. For example, in BCD you have 2. In XS3 code, it will be this 2 plus 3. You add 3 to it. That is, it is excess of 3. So 2 plus 3, you will get 5. So this is the XS3 code for the BCD number 2. This chart shows the relation between the BCD and the XS3 code. You can see here the BCD value ranges from 0 to 9. So 1001 is 9. See the XS3 code, there is no 000. It means it is not starting from 0. Rather it starts from 0011, which is equivalent to 3. So whatever BCD value you have here, add 3 to it, you will get the XS3 code. So XS3 is BCD plus 3. You can check any value. So if you take this 4, 0100, add 0011 to it, it will become 0111. This is equivalent to 7. So 4 plus 3, it will become 7. Now we will see how to convert the given XS3 code to BCD code. So already in the channel we have uploaded BCD to XS3 code converter. Now we are going to do in the reverse order. That is, if XS3 code is given, how you will convert to BCD. Let us start with B0, this output variable B0. So now in XS3 code conversion, you should be very careful because the code doesn't start with 000. Rather it starts with 0011. It means that the min terms 0000, that is the min term 0, 1 and 2 doesn't have any value here in this input variables. Okay. So in XS3, these 3 doesn't exist. 0000 or min term 1, min term 2 is not there. So these should be taken as don't care. So all 3 will be taken as don't care. So the first value is 0011. So 0011 it is equal to 0. Next one is 0 1 0 0. So again this will be 1. Again this is 1. After that 1 0 0. So this is 1 and here it is 1. Here it is 1. And after that you see 1 1 0 0, there is no value because after that BCD value will not be there. So remaining terms are don't care. Now let us combine the map. So you can combine these two together. So you will get B naught equal to E naught bar because in both the cases E naught bar is common. For B1, let us mark the don't care first. Then how many ones are there? 4 ones are there. Mark it. Now remaining don't cares will be here. So let us combine these two ones together and these ones together. So this is the expression. For this one the common term is E1 bar E naught, and for this the common term is E1 E naught bar. Next for B2, same, you mark the don't cares first and ones. How to combine this one? These two, one can be combined with this don't care, then here 1 is there, here don't care is there. So all 4 corners can be combined and this one is again separate, combine this one. So you will get 3 terms. Next for B3, only 2 ones are there. Let us mark that. Remaining don't cares. How to combine the one? This one can be combined like this and this one can be combined like this. So you will get 2 terms. So now we have finished the code conversion. You can draw the logic diagram as in the previous case. Now we will see the equations what we have got in BCD to XS3 converter and XS3 to BCD converter. There is some similarity between these two which will be helpful to study for the exam point of view. So E naught is equal to B naught bar, E1, E2 and E3. If you see XS3 to BCD, same term is coming here. E naught equal to B naught bar, here B naught equal to E naught bar. So the first one has similarity, whereas the other thing, this is XNOR gate whereas this is XOR gate. Only little bit difference will be there, so it will be useful for studying. If you want to know more about 4 variable K-map or other code converters, you can refer to the playlist Digital Electronics in Read Electric Vehicle channel. Apart from that, power electronics, solid state drives, circuit theory and basic electrical engineering videos are also available. If you like the video, do subscribe to Read Electric Vehicle. Thank you.